Okay, any question about the last question? Okay, so for the next one, I would like you to take the lead, okay? See if you can do everything up to step 2 at least, right? If you could, you can carry on to step 3, get the relation, okay? So here we have a water tank, right? Also try to make a picture, right? Has a shape of inverted circular cone. So inverted circular cone, think about what that looks like. Right, with the base radius, so it's a container, right? Radius of 2 meter, height of 4 meter, so that's the dimension of the cone. And then now we have water instead of air, right? Water is being pumped into the tank at the rate of that, so that's the rate. Find the rate, right? Find the rate at which the water level is rising. When, right? When means at the moment when the water is 3 meter deep. Okay, so try to break down the question, right? And then get the important words. So once you get up to step 2, please raise your hand. Okay, and if you are sure, you can continue. Okay, but raise your hand if you get to step 2. And also pictures too. Okay, I need you to draw the pictures. So in the picture, right, video has variable in there. Snapshot has no variable. Please raise your hand if you got the pictures and also the 2 steps. Okay, Jesse, can I see your inverted circular cone, what it looks like?
Okay, I can try.
Yep. Okay, so that's a cone, but this one is upright, it's not inverted, right? Because if you want to use it as a tank, right, like a cup, you have to flip it.
Wait, I have a question.
Yep.
How is the cone standing then?
It probably has a support, right? Maybe.
Oh, okay, that makes more sense. I was thinking like which way it's supposed to be. I was thinking like ice cream cone, and then I was like inverted is this way. I'll redraw it.
Okay. Yeah, if yeah, only up. You have to invert it to hold water in there. Okay, and then what variables would you put in there?
I did R for radius, H for height, and V for volume.
Okay, what about some numbers? Any numbers go in there, like the 2, the 4, the 3?
Oh, I thought we were only supposed to do that for snapshot.
Snapshot is for the moment that we're interested, right? What's the 2
Oh,
for?
so R would be 2 and height would be 4.
Where's the R and
Wait, I'll try to draw it.
Yeah. So can you tell me where the variables are and where the numbers are?
Okay. Do you want me to draw it?
Yeah, yeah, yeah. Okay, so that's radius and height. And you're saying those two are the variable.
Oh, and there also needs to be volume, right?
What do you mean? A volume? Yeah.
Yeah, okay. I'll draw that out too.
Okay. Okay.
That's kind of ugly, but
It's okay, we get it. So we have three variables here, V, R, and H. Remember, variable means they are changing, right? So if you say that's the R is the radius there,
oh, but the radius isn't changing and the height's not changing
how come?
because they're fixed. It's not like it doesn't vary depending on different stuff.
So because the 2, the 4, they are measurements for the container, right? So it's
Yeah.
not a variable. If it
Uh,
then the container is growing, right? Changing.
yeah.
Yep. So what's actually changing here then?
The water level.
So you got to also show the water then. That's the
Uh,
part about this, right? You have to show the water, and your variable should be about the water.
so like W or something.
So where's the water? How do you show the water?
Let me try and draw it.
Yeah. Do you want me to zoom in so you have a bigger space?
No, it's fine.
Okay.
Thanks though.
Yep.
Like this is the water level.
That's a very dirty water. Oh, scary.
Yeah.
Okay, yeah. So where's the R?
Um, oh, I guess the R would be like dependent on where the water level is, right?
Yeah, yeah.
So
So
it's like
mhm.
because the R is changing, or like the radius of the water is changing.
Yeah. So
Okay, I think I'll just have to erase this.
use a different color.
Oh, okay. No, that's a oopsies. Um, there we go.
Oh, nice.
Thank you.
Blood.
Oh, that's ugly. I don't know what that is.
Okay. And then,
Then that's the R.
okay.
And then this is the height.
Yeah. Okay. And then what about volume?
Um, hold on, let me erase this stuff because it's kind of ugly. Okay. The volume. No, I don't want that. No. This. Like this whole thing is the volume.
So it's the pink one, right?
Yeah, the pink part.
Okay, so all the variable is talking about the pink part, the juice, right? And then the 2, the 4, they are just the container. So they will still stay, it will be on the video and snapshot as well. It will be on both because it's always there, right? No matter, right? But then on snapshot, the water level is fixed. Okay, very good. That's the picture we want. Okay, I'm just gonna retrace it. Okay. Right? And then we get water level, right? And I'm gonna make the water also 3D as well, right? Okay, here it is. So we have water level, This part is the height. Here is the R, right? And then radius for the container is fixed at 2, and the height is 4. Okay, and then we have R and H, and then of course the volume of the water is also changing. So that's V.
All right, sir.
Yep.
Then isn't there like kind of two variables for this one then?
This one has 3, V, R, and H.
Oh no, I meant like when we're finding the derivative of stuff.
Yeah, it will have, more than
Okay.
this.
Okay.
Okay, so you can, we will get there, but you can think about what to do with that, right? Okay, so over here, what's the moment that we need to take the snapshot? Carrie?
Is it like when it's 3 meters?
Yeah.
So would it be like the kind of like similar to the first one? So similar to the video, like how you draw.
Mm-hmm. Okay, so when it's 3 meter deep, that means which variable becomes 3?
The height.
Yeah, the height. So when h equal to 3, okay? So let's make it higher, right? So it'll be somewhere up here now, right? That's the moment you keep on rising, right? And you take the picture, freeze the moment when it goes up to 3. So there is no variable now, okay? So this part is 3. And then radius, of course, is also fixed, except we don't know, okay? Some number also frozen, okay? And then volume, same thing, it's also some certain volume. Okay, so let's check. How about the rest of you? Have you all finished step 1 and 2? Can you raise your hand if you finished? What is step 1? What's the given rate? Leon, do you have?
The 2 meters cubed per minute.
Okay, and what symbol would you use for that?
dV over dt.
Okay, very good. It's talking about the volume, right? Volume is increasing, right? Because it's positive at 2, right? We're pumping in. That's why we know it's increasing, right? If the question says leaking out, right? There's a hole at the bottom. It's leaking out at a rate. Then you need to use negative meter cube per minute. Okay, and then we have something that we want to find. So Jeffy, what's the unknown?
The height.
So what's the symbol?
dH over dt.
When?
When the height equals 3.
Yeah, okay. And that's the target. Okay, so step 3 is to relate, right? So what will be the variable that we want to relate? John?
To relate the, wait,
Well, you can look at what we did before, right?
yeah. Oh, just the height and the volume?
Yeah, so H and V. Okay, so we need some formula that has volume and height. Or think about if you know the height, how do you find volume, right? What's the formula for finding the volume of the water? If you forgot, right, look up your agenda or search online, okay? Does anybody know what's the volume for the water?
Pi r squared h over 3.
Pi r squared h over
3.
yeah,
No, just the h over 3.
just the h over 3.
Bro, it doesn't matter though, because it's everything like.
Oh, yeah, never mind.
Okay, so it's okay, right? If I want, I could also put it at the front. I can write it as 1/3 pi r squared h, right? Same thing. Okay, so now right now we have R and H, right? So think about it, right? Because our goal is only H and V, height and volume. But if we keep 3 variables here and then we continue with step 4, then you will start to have dv dt, right? If you prime, right? You will have dr dt and you also would have dh dt. But we don't have dr dt, right? Dr dt is not given. Then we will expect to run into trouble later, right? So we need to do something first, right? Before we can start turn them into rate, right? Before we do step 4. So we need to somehow get rid of the R, right? Because we don't have dr dt in the question. So how can we get rid of the R? How do we rewrite the R?
Hey, Jason.
Yeah.
The radius is fixed at 2, right? So can you just put 2 into R and then
Okay.
rewrite?
So can anybody answer this? Can we put 2 into the R?
No, because the radius, it's the radius of the cone is 2, but the radius of like the water isn't 2.
Does that answer your question, Jeffy?
Yep.
The 2 meter is for container, right? So it's never changing. But then the variable that we're using here is all about water, right? It's the snapshot, right? This is the snapshot of water. Okay, so all these are changing. We cannot sub in any number into the variable, right? So what's the relationship between the radius and height, right? So then we can somehow replace the radius. So everything will be in terms of height. Take a look at the picture, okay? See if you can see any connections between R and H.
I mean, when R gets bigger, H gets bigger too, right?
Yes, yeah, of course. That's
Wait,
correct.
Jason.
Yeah.
Since it's R squared, would it be dv over dh?
dv. What do you
Like
mean?
the change in volume over the change in height would just be R squared. Or is that? Wait,
We're
no.
not doing derivative yet.
Oh, okay. No, I'm thinking of something else.
Yeah, okay. And if you are taking derivative, it's always dt in this section, right? Because we're all talking about rate. Right now, our trouble is having too many variables. Okay, we only need to have h and v, but then the relationship that we got, we have v, the radius, then height, right? And if we just continue to prime, you will get dv dt, dr dt, dh dt come up, and that's not good, right? We don't have dr dt to sub in, so we need to replace. So try to look at the picture. What's the connection between R and H? What I mean is, if you know R, can you get H? Or if you know H, can you get R?
H is 2R. I'm just
How do
kidding.
you know?
Oh, I was kidding. It's not.
No, I didn't say it's not.
Oh, I don't even know. I was just guessing.
Guessing, huh? Okay.
Yeah.
Any
I mean, it looks about right.
reason to back him up?
I had a gut feeling.
You have a gut feeling. Okay.
Yeah.
Anyone else? If you know height, how do you get radius? If you know radius, how do you get height? Is there like a mathematical way to show? Something to do with triangles.
Oh, half base height.
Half base height. What do you mean?
You know, like the area.
Oh, area of triangle, but no, we are not using area here.
I was close though. You gotta admit.
Another hint, okay? Think about similar triangles.
The ratio?
Ratio, okay. Do you see how we can set up a ratio?
Oh my goodness, 2 to 4 is
Okay.
1 to 2.
We have radius to height. You can draw a line down, right? Then you can see a big triangle and a small triangle. This is called a similar triangle, right? It's just blown up. So you have radius and height, and radius and height. Okay, so that will connect the radius and height together using similar triangle. So please write it on the side, right? So similar triangle. We have R to H should be 2 to 4. Okay, we can simplify this. R to H will be 1/2. So that way we can use this to replace, which variable do we want to replace?
H.
We want to replace.
No, R, because we don't have dr dt. We only have dh dt.
That's right, okay? So that's why we write this out, right? Relate H and V. So we know we don't need R, okay? So I want to get rid of the R. So now we can go back in, right? 1/3 pi R square H. So what do we put inside the R?
Half R or half H.
Half H, yes, okay? So using this thing, right? You can isolate the R, then replace it with the R, okay? So now we can simplify this a bit more. Half H squared, that will be what? Half H times half H, right? So multiply everything together. So what's the final expression? Can you raise your hand if you get a final expression? Simplify the expression, please. Get rid of brackets, multiply things together. Okay, Nicole, do you have the expression?
I think so. Is it 1/96 times pi?
96. How did you get 90? Oh, did you? How did you get 96?
Oh, wait. I think I did it wrong. 1 second.
You got to keep the variable there. Don't sub in 90 numbers. Okay, how about Lex? Do you have an expression?
1/12 pi h cube.
H cube. Okay, Nicole, did you get that?
I am. Oh yeah, I got it. Yeah.
Yeah, okay. Right, so once you get here, right, now you have something you need, right? Something you wanted. You just want to have a relationship that is between V and H, right? You know the height, you can find volume. You know the volume, you can get height, right? Because that's the given and unknown. All right, next step, we need to prime. Right, remember all the variable now, they are function of time. So please prime this. When you finish prime, please raise your hand. Is there anyone having trouble doing prime?
I have a question.
Yep.
How would you prime pi?
Pi is a constant, right? So just like 1/12,
Oh, okay. So it'll just be. Oh, okay.
it'll stay there. It'll stay there. Okay, just like the last question, right? 4/3 pi. You just keep it at the front, right? It doesn't do anything. If it's multiplying with a function, the constant will just stay beside the function, right? But if it's by itself, alone, right, adding a constant, then the prime of that constant will be 0, okay? Anyone has trouble taking derivative? Please raise your hand if you finish the prime. Okay, Carrie, can I get your answers?
Is it so dv over dt equals 1/12 pi times 3h squared times dh over dt.
Yeah, very good. Okay, so h is a function of time, and that is inside the cube. So you will need to use chain rule. Okay, but v is by itself, so it just becomes dv dt. And
Jason?
then we are interested in finding dh dt, right? Jesse, you have a question?
Could I simplify it, like get rid of the 3 and make it just over 4?
Of course, yeah.
Okay.
So let's simplify it. dv dt is pi over 4 h squared dh dt. So finally, step 5 is to find dh dt. Okay, so same thing, please leave your answer in exact. So only step 5 is the moment you look at the snapshot. Okay, because you're solving the question now, right? So look at snapshot. Okay, and then any other time, right? Any other step, you don't look at snapshot. So let me know if you get an answer. Please raise your hand. Exact answer. Okay, Emily, what do you have?
I have 8/9 pi.
8/9 pi. Pi on the top or bottom?
Bottom.
Bottom, okay. Anyone else got something different? Or we're all the same? Joan, what do you have?
I got the same thing.
Same thing, okay. So that's the 9. Yeah, looks good. Okay. So what will be the unit then? Leon, what's the unit for this?
Meter cube minute.
Meter, this is for the rate of what?
Of water level rising.
Rate of height, right? So
Oh,
do we put cube?
no, just meter.
Yeah, okay. If we're measuring the height, right, length, it's only meter, right? And this one is per minute. Okay. Any questions? Nicole, how are you doing? Any trouble?
I did it wrong.
Okay, which part are you on?
I'm just doing the last step.
The isolating, right?
Yeah.
Yeah, okay. So let me know, okay, if you have trouble getting, you can write the answer down on the side, okay, 8/9 pi, okay? And then you guys can take a look at next one now, okay? So this is the third one. So this time I'll let you see if you can carry out all the way to step 5 then, okay? I'll give you more time for it. Make your own pictures, video, snapshot. If you have the pictures, can you raise your hand? And then I'm gonna show my pictures. See if you get the same, okay? Put the variables and numbers into the pictures. Right, so let's draw the picture, okay? So I have a ladder against a vertical wall, right? I'm going to put a wall on the right side. You could put it on the left side, doesn't matter. And of course, there's a ground, right? And then you place the ladder. Okay, I'm just gonna make it 2D, okay? So it's not too confusing, right? And then ladder is 10 feet long, right? This one is never gonna change, just like the container, right? It's never gonna change, so you have to put it, right? So 10 feet long. The thing that's changing, right? The bottom of the ladder is sliding away at the rate of 1 feet per second. So which part is changing? What will be the variable? What do you guys have? What variable?
The variables would be like I put H for like how far up the wall the ladder is.
So like from here to here.
Yeah. Like that's changing because and then the other one I put D, like how far the base of the ladder is from the base of the wall.
Okay, so
'Cause
what variable did you use?
I use D like for distance.
Okay, yeah. Normally, right, it's good that you use your own variable, but I'm gonna keep it simpler. Okay, I'm just gonna use X and Y for horizontal and vertical. Okay, but it's the same thing. Okay, you could use H and D.
Oh,
Yeah, doesn't matter. Okay, so I'm gonna use Y there, and then X here. Okay, as the ladder slides away, right? Slides away, then this part, the top will drop down. Right? So that means the distance, right? Those X and Y will be changing, right? So that's the variable. And that's all the variable that you have. Okay, so you can start by writing out the 5 steps.
Jason.
Yep.
What would like the formula be? Now, like the other ones, we had like volume equals whatever.
Mm-hmm.
For this one, is there like a formula for like the relationship between like the height and how
right?
it's sliding?
So you got to think about what you want to relate, and then any formula that can connect them all, then that will be the formula.
Okay.
So the moment that we take the snapshot, when is it, John?
When the bottom of the ladder is 6 feet from the wall.
Okay,
So
so
X
when,
is 6.
yeah, very good. Okay, when X is 6, and of course the Y will also be fixed. Some number, we don't know.
Sir,
Yes?
if it's a triangle, can we do like area?
Area, well, as long as it has all the variable in there, then that's a relation, right?
Yeah.
And if you
Okay.
use area, then if you prime, think ahead, right? If you prime it, you will get dA dt,
Yeah.
right? And would you have dA dt to sub in?
No.
No, then you will have trouble, right?
Oh, okay. So I gotta think of
about
something
why
else.
it works and why it doesn't work, okay?
Okay. Thank you.
Okay, Leon, what's given?
The rate.
Yeah, which rate?
I guess dx over ds.
Dx over,
ds or dt, sorry.
yeah, we never have, it's always dt, right? Dx dt is,
1 feet per second.
so how do you know it's a positive number?
A good question.
Yeah, I know. I always ask good questions. How do you know it's a positive 1? Why not negative 1? Emily?
Because the number is increasing.
Yes, okay. You have to look at the picture, think about the picture in motion, right? Video, right? X is increasing because it's sliding down, right? If they change the question, they tell you that the ladder is sliding down at 1 feet per second, then you know the given will be dy dt, and then it has to be negative 1. Okay, you have to look at the video, think about whether the variable is increasing or decreasing, then decide to put positive or negative. Okay, what's the unknown? Nicole, what's the unknown?
dr over dt.
Where's the r?
The rate.
Huh? Which rate are we finding?
How fast the ladder slides down the wall.
So that's gonna change which variable in the picture?
X. Oh, wait.
Sliding down.
Y.
Yes, okay, the vertical, that's the up and down, right? So your unknown rate should be,
dy over dt.
yeah, everything is rate, okay? dx dt is also rate. dy dt is also rate. So it's better not to use dr dt, right? It doesn't tell me which rate we are talking about. Right? When? What's the moment that we want to find?
When,
Yeah.
oh, sorry.
Yeah, you see, go ahead.
Oh, when x equals to 6.
Okay, x equal to 6.
Also, I have another question.
Yeah.
Okay, so like I did Pythagorean theorem because I literally don't know what else to do.
Okay.
But like, I don't know if that has anything to do with anything.
Huh? What do you mean?
Like, because I found the height of like how high up the ladder is,
Yeah.
but I don't know if that has anything to do with anything.
Okay, you said you use which relation?
A squared plus b squared equals c squared.
And then you are not sure if it's the right one?
Yeah.
Okay, so how do I apply to my picture then? How do I write it?
So for the snapshot part.
Yeah, we don't look at snapshot now.
Oh.
We look at it at step 5.
Okay. So x squared plus y squared always equals 100 because the hypotenuse or like the length of the ladder doesn't change.
Okay, so let's see if this is the relation that we want, right? So the easy way to check is to figure out what variable we want to relate. So you look at your given, right, and the unknown. We want to relate what and what?
Wait, are you asking me?
Sure.
I'm relating the length of the freaking what's it called? Like how far it is away from the wall to how high up it is on the
variables are
x and y.
Yeah, so we just want to relate x and y. So you just need to check if your relationship has those two variables. If it does, then that's the right one. Okay?
Oh, what? Wait, so was it correct or?
So you tell me, do you see x and y in your relationship?
Yeah.
So is it correct?
Oh, are there any other ways to do it though? Because I just did that because I was feeling like I didn't know what else to do.
Well, I don't know. If there's any other way, let me know, okay?
Okay.
Okay. Well, if as long as you can come up with with a relationship that connects x and y. Connecting x and y means if you know x, can you use it to find y? If you know y, can you use it to find x, right? Then that's the relationship. So far we got several relationships, right? We have the volume of sphere, right? Formula, volume of a cone. We also have similar triangle. That's like a relationship, right? Here with Pythagoras, it could be anything. It could even be trigonometry. If it has to do with angles and the side, right? If angle is changing and a side is also changing, right? Then you need to use trigonometry. Okay, so it could also be area. If the question mentioned about area is changing as at the same time the height is changing, right? Area triangle, then you will need to use area triangle. So for a triangle, there could be 3 ways, right? You could use Pythagoras, you could use trigonometry, you could also use similar triangles, right? And you could also use area. Did I say area before? I forgot. Okay. So anything you learned before, and you just check if they have what you want. Now we do the prime. Joan, what's the prime?
Oh, I haven't done it yet just because I was listening to the whole thing, but let me just do it quickly right now.
Yeah, no worries. Okay, anyone has question about what I just said? Okay, how to check the relationship?
Wait, Senor?
Yeah.
In this case, we have to apply chain rule for x, right?
Yeah.
Okay.
Yeah, because x and y, they are both function of time. and you need chain rule if they are inside some function.
Wait, I have another question then. Because after I find x prime, I need to how do I say it? I need to plug in like 2 points, right?
Yes.
So in this case, would I have to find, like, I would actually have to use a squared plus b squared equals c squared, right?
Yes.
Oh, thank you, sir.
Yeah. Okay. Because the relationship will always exist, right? It's always there, as long as it's a right triangle. Joan, got it?
Yeah, is it just so dx over dt?
Mhm.
Or like, do you want me to say out the whole thing or just the primed part?
The whole thing, the first step after you prime.
Okay. So 1
1.
equals. Wait, I don't know if I'm doing this right, like in the right order.
You prime from left to right, right? You need to prime both sides. So what's the prime of x squared? Joan?
Hi, sorry, my internet connection says it's unstable. I couldn't hear if you were talking or if anyone was talking.
So let's start with derivative of x squared. What do you get?
2x
Okay, and then?
plus 2y.
Not yet, because x is a function of time, and
Oh,
it's inside the function square, right? So you need
right. So would it just be? Wait, I'm slightly confused. I don't know what it would be.
Okay, you need to treat the x just like the y. All the variables, they are like y. They are all function of time. So if the function is this x function is inside a square, so we need to apply the chain rule. You understand, Joan?
Yeah, so it would just be 2x and then times x primed or
Right.
dx. Okay, yeah, dx over dt. That makes sense.
Yeah, so x and y or any other variable later on you see, right, it's always function of time. So you have to treat them all like y variable, okay, like what you learned before, okay? And then continue. Let's finish this up.
2y times dy over dt.
Equals
100.
yeah.
Or wait, no, just kidding, equals 0.
Okay, very good. Right, so now that's it, right? So this,
Wait, what?
huh?
I thought it equals to 1.
Why?
Because doesn't dx over dt equal 1?
Dx over dt equal 1? What?
Like, how the other ones we did,
He's talking about the given, I think, because the given's 1, the dx over dt is
yeah,
1.
thank you.
Hmm?
Like if
That's
you
what-
look at the given for example 5, it says dx over dt equals 1 feet.
Yeah, but we use that when we are solving, right? We're not solving yet.
Oh, what? Wait, how come we have a 0 then? Oh, because we primed it.
Yeah.
Oh, I'm so
we are
sorry.
doing implicit differentiation, right?
I'm
We
so
prime
sorry.
both sides. Are we good?
I got super scared for a second.
Okay. So now when we are solving, then you can start plugging stuff in, okay? We are interested in finding dy dt. So you should double check, do we have everything else, right? Do we have x? Jeffy, do we have x?
Oh wait, I'm a little confused about something. You know
Yeah.
how in the previous questions you said how like pi is fixed, so we don't have to prime it.
Pi, the
Like in
previous
the
one?
previous questions, like 1/12 pi.
Yeah.
You know how you said that was fixed, right? So we don't.
It's a constant. It's a
Yeah,
constant.
wait, but like, I'm a little confused because the 100 doesn't that refer to the ladder? Like the length of the ladder doesn't change, right? So when we
Yeah.
prime, why would it go to 0?
Because when you prime a constant alone, then it will goes to 0. Think about this one. Okay, look at the example on the side. Okay, you don't need to copy this. If I have y equal to 5x squared, how do you
Mhm.
prime this?
10x.
Yeah, so the 5 stays, right?
Mhm.
Multiply with the 2, right? Times 2x, right?
Yep.
Because the phi is multiplying with the function x squared. So if the constant is beside a function, it will stay. Now,
Oh.
if
oh.
I have, for example, like this one, if I have another one, x squared plus 5,
Mm-hmm.
what's the prime?
2x.
What about the 5? What happened?
It becomes a 0.
Yes, because it's alone by itself.
Okay. Yeah, I got it.
Okay, now we have 100. 100 is alone. So when you prime,
Mhm.
it goes to 0. Make sense?
Yep. Okay.
So now we sub in the number. The 2 times, what's the x value we sub in? Emily?
You sub in the 6 and the 10
Okay, 6
and the 1 foot per second, I think.
dx dt. Yeah.
Yeah.
Okay, plus 2y. Do we have the y?
Yeah, it should be 10. Oh, jokes. No, we don't have the y.
Okay.
Wait, no, do we? No, we don't. Wait.
Oh,
No. No.
we get it though? We need to look at a snapshot, right? Step 5, we need to look at snapshot. Can we get a y?
10
Yeah.
squared equals
8.
10 squared.
How do you get an 8, Leon?
The Pythagorean.
Yes, okay, because at a snapshot, even though a snapshot is still, Pythagoras still works. So that will be 8, and then dy dt equals 0. Okay, so when you get a final answer, please raise your hand. I need to lower your hands first. Okay, raise your hand if you got the final answer.
Bro, what?
Huh?
I'm so confused.
Where?
Okay, I was listening to you talk, right?
Yes.
And then I understood it.
Okay.
Like everything makes sense.
Yes.
And then I looked at my I looked back down at like the work that I like thought I understood what I was doing,
Yeah.
and it's completely different. I don't have 2x anywhere.
2x. Because you prime it, prime the outside, so 2x. Prime the inside, dx dt.
Oh, you didn't finish writing it. That's why, right?
What do you mean?
Wait.
Which line are you talking about? Step 4?
No, the stuff you have written on the side. Or is that not part of the work? Did I just assume that was part of the work?
On the side, this thing?
Oh, okay.
Oh, that was my question. That has nothing to do.
Oh,
Yeah.
okay, sorry. I was like listening
thing
to it.
what
I thought
I
that
was
was part of the work.
I was trying to explain to Jeffy.
Yeah. Okay, sorry. I got kind of confused. Never mind. That's my bad.
I crossed it out. Okay, Carrie, what's your dy dt?
I got -3/4.
-3/4. Joan, what do you have?
Same thing.
Same thing. Jeffy?
I have the same thing.
Okay, and Emily, why is it negative then? Emily, why do you?
Oh, sorry. I had my mic muted.
It's okay.
But the y is decreasing, right?
Yes, yeah, negative because it's decreasing. So if you get something that's positive, right, then you will know something went wrong. Okay, so you got to keep that in mind. Positive, negative sign, it tells you a lot of stuff. So here the unit should be feet per second. Okay, let's see if we can finish this in 5 minutes, right? So question 6. Okay, go ahead. Same thing.
Wait.
Yeah.
I got -5/4.
Uh-oh. You got all the numbers the same? The solving, the subbing in?
Uh,
If you stop in the same,
yeah, yeah.
then you isolate it wrong. Double check. Okay, you can do this.
Oh, I did the opposite way. My bad.
Yeah.
I see it.
Yep.
Thanks.
Okay, so everyone, please try question 6. Going north and going east. What rate distance between the boat increasing? Okay, if you have the final answer, you can raise your hand. I'm gonna go ahead, draw the pictures, okay? And then you can take a look if it's the same as yours. So we have harbor. Boat A is traveling north. Boat B is traveling to the east. Boat B is going faster, right? So I'm gonna draw longer. So this is boat B, this is boat A. And we also have something that's changing is the distance between the boats. So you could call that D. Okay, I want to check the variable. What other variable should be in the picture?
I
How
mean,
far the boats
like,
have,
Which part are changing?
like how far the boats have traveled?
Yeah, okay, so we can basically, to keep it simple, we can call the distance here B then, right? Distance traveled by boat B will be B. Distance traveled by boat A will be A, right? So we don't have to introduce other letter. Keep it look simple, right? So we have A, B, D, 3 variables. Snapshot, when do we take the snapshot here?
at 4 p.m.
4 p.m. Okay, when?
Yeah.
Okay. So 4 p.m. they have traveled a lot, right?
Wait, sir, I have a question.
Yes.
There's like, how do I say this? You know how like the other questions we only had like kind of one rate of change?
Mm. Yeah. Oh, you mean one given?
Or yeah, this one we got 2.
Okay.
So
Just follow the steps. Don't worry.
what if we? Oh, okay.
Yeah. Keep pushing, right? And then you'll see what happens. You got to trust the steps. Okay. Write down all the given. Write down what you are looking for. Get the relationship that connects them all. Okay. And then just do the prime. Okay, what numbers goes on snapshot then? Because right now it's all empty. Any number that we should put on the snapshot?
Yeah.
Okay, Jesse, what number?
On the up or for A, you would get 24.
24,
Yeah. And then B is 32.
32.
And then D is like 50 or something, right? Because like 3, 4, 5.
Is it 3, 4, 5?
Not 40.
So, right? Oh no, it's 40, not 50.
40?
Yeah.
All right, any question? Anyone has questions about how those numbers are found? Okay, we started at 12 noon, right? 12 p.m. goes for 4 hours. So then you use the 4 hours to find the distance they travel. Okay, 32 mile for boat B. Okay.
Wait, Jason,
Yep.
for boat A, so it's traveling north at a rate of 6 miles an hour, right?
Yep.
And then B is traveling at a rate of 8 miles an hour.
Yep.
Didn't you figure out the rate, but the distance that's increasing between the two boats? Can't you just do 40 miles divided by 4 hours?
40 miles divided by 4 hours.
Because you already have the distance between the two boats at 4 p.m., right?
Mm-hmm.
And you know that they traveled 4 hours already.
Yeah.
So can you not just do 40 divided by 4 to get like 10 miles an hour, and that's the rate?
Yeah, you could do it like that. Yes.
But do you still want us to do it like?
Yeah, because
Oh,
I could change this question very easily. So then this won't work. For example, I could say it starts later or it starts at a different place.
Okay, I was just wondering because I'm like, it seems kind of simple.
Yeah.
Okay.
At the end, try to do this and see if you get the same answer as why you do it the other way, right?
Okay. Got it.
Yeah, if they are all given the rate, then you can do it like that. Okay, so given rate, we can say dA dt going north is 6. We are also given another rate, is 8. d dt when 4 p.m. So
Wait, sir, I have a question.
yeah.
Okay. Like, how do I know? Because you know how like distance is like one-dimensional, right?
Yeah.
So like, how do I know which one I'm supposed to prime for this one, like A or B?
When you prime everything. Implicit, you prime both sides.
Oh, because they're both squared. My bad. Thank you.
Yeah. Okay, so we want to relate all the variable that you see on the top, right? A, B, and D. So what will be the relationship between them? Leon?
Would it be the Pythagoras theorem?
So how do I put it in?
A squared plus B squared equal D squared.
Yeah, okay. You can double check, right? Does it have the 3 variable? If it does, then that's the right one, right?
Wait, Jason.
Yeah.
I kind of meant like, how do I know which one is supposed to have like you know how like implicit we usually have to find y prime?
Mm-hmm.
Like for this one, how do I know which like prime I'm supposed to be looking for?
Well, which prime are you looking for? You tell me.
Oh, D prime, right?
Yeah.
Oh, because we're trying to find it. Oh, never mind. That was a dumb question.
No, it's no question is dumb, okay? I'm just asking you back. Okay. So if we prime both sides, right? So it will be 2a dA dt plus, okay, how do we carry on here? Nicole?
A 2b dB over dt
And then
equals 2D.
2D.
Is there d over dt?
Yeah, because all the variable, they are function of time, okay? And if the function is inside another function, in this case, it's a square, right? Inside a square, you got to use chain rule. So we want to solve for d dt, right? So you must check, do we have everything else? Okay, and step 5 is the moment you look at snapshot to fill in the numbers. Okay, so fill in everything. 2a, a is 24 at that moment, right? 4 o'clock. And then that will be 6. And then 32. Okay, if you finish final answer, please raise your hand. And then we have 8. 2 times 40 dt. Everybody has to get this, okay? Final step, isolate dt. Raise your hand if you got it. Okay, so everyone turn on your mic. Can you guys say out the answer then? Okay. 1, 2, 3, go.
7 over 5.
10.
10? Oh my god.
Yeah. Okay, you guys can go have dinner. Okay. I'll see you next class.
Wait, Jason, can I ask you? Can I
Thank you.
can I ask you a question?
Thank you.
Because I got a question. I got
Yeah.
a big question. Wait. Okay. Wait. How do I know? Okay. Like, if they're all squared, I have to do chain rule for everything.
Yeah, if they are in functions, right? Doesn't have to be
Oh
square.
yeah.
For
Because
example,
they're still a function.
if the variable is inside sign, then you need
Yeah.
to do chain rule, right? If it's inside square root, you also need chain rule.
Yeah. Wait, because like I was just like that's why I was kind of confused. I know like other ones, you know how like other ones we might just do 2a plus 2b equals 2d or something.
Yeah.
Like,
Because the other one, we did not treat it as a function, right? We treat it as
Yeah.
like x.
oh, but since they all have dA over dt and stuff, then I know I have to prime all of them. Or like I have to include the a prime, b prime thing, right?
Yeah, they are, a is depending on time, right? They are
Yeah.
all dependent.
Okay. Oh, and then also, can I ask a question about? Oh, never mind. I figured it out. Thank you.
Okay.
Okay. Bye bye. Thank you.
Okay. Bye-bye. Good night.